Today we're going to look at solving a system of linear equations graphically. Well, the solution to a linear system can be seen by graphing both equations on the same grid. If the two lines intersect, the coordinates of the point of intersection, xy, is going to be the solution to the system. Now here's our two equations. First of all, if we plug in zeros for x and y, we will find our x and y intercepts. So in our first equation, 3 times 0 plus 2y is negative 12, which means 2y is negative 12, or y equals negative 6. That will be one of our points for our graph. When x is 0, y is negative 6. That's where our y-intercept will be. Now we'll try when y is equal to 0. 3 times x plus 2 times 0 is negative 12. Which means 3x is negative 12, and dividing both sides by 3, x will equal negative 4. So there's 2 points for that graph. For the second graph, if I plug in y is equal to 0, x is equal to 0, we'll get negative 2 times 0 plus y equals 1, or y is just equal to 1. And if y is equal to 0, that'll be negative 2x would equal 1. And dividing both sides by negative 2, we would get x equals negative a half. Now to plot those points on the grid, you'll notice the first point, here's our graph, is if x is 0, y is negative 6. And if x is negative 4, y is 0. And the y-intercept and x-intercept for the other graph is going to be at 1, 0, and negative 1 half is 0. Now, if we find the point of intersection, you will notice that it's when x is equal to negative 2, y equals negative 2. So the point of the ordered pair, negative 2, negative 2, is called as the solution to our system of equations, because that's the point that will work in both of our equations. Let's try that again. This time we're going to show you how to use the graphing calculator to do this. Now in both these equations, we are going to have to solve for y, because that's the only way we can enter it into our calculator. So for our first equation, we have 3x plus 2y is negative 12. I would subtract 3x from both sides of our equation, and then I would divide both sides of the equation by 2, and that would leave me with y is equal to negative 3 over 2x minus 6. In the second equation, I would add 2x to both sides of the equation to leave me with y equals 2x plus 1. Now I'm going to enter these two equations into my graphing calculator by pressing y equals. And under the first one, y1, we're going to enter it as bracket negative 3 divided by 2 bracket x minus 6. And the second one is going to be 2x plus 1. Then we're going to press graph. Notice that the negative is the negative sign in front of the 3, whereas the minus sign is a different sign on your graphing calculators. It'll be negative 3 over 2x minus the 6. After you've done this and you've got a picture on your graph, you're going to press second trace 5, which is calculating the intersect. Then you have to press enter 3 times. And what that will do is it's going to tell you that x is going to equal negative 2 and y is going to equal negative 3. That's your ordered pair. Let's try this one. Solve this linear system. 2x plus 3y is 3, and x minus y equals 4. So I would subtract 2x from both sides, and I've got 3y is negative 2x plus 3. And again, dividing both sides by 3, we will get y equals negative 2/3 x plus 1. Second equation, I will subtract an x from both sides, and now I will multiply everything by negative 1 to make it positive y equals positive x minus 4. Now when I graph these two equations, they're going to intersect at 3, negative 1. So the solution to our system appears to be at 3, negative 1. But we have to verify that to make sure that it's going to, first of all, be that. So we're going to have to plug x equals 3 and y equals negative 1 into both of our original equations and see if it works. And in the first equation, we end up with 3 equals 3. That works. And in our second equation, we end up with 3 minus negative 1 equals 4. That one works. So we verified that 3, negative 1 is the solution to our system's equations. In the second one, it says Jayden left her cabin on Waskesiu Lake in Saskatchewan and paddled her kayak towards her friend Tyrell's cabin at an average speed of 4 kilometers an hour. Tyrell started at his cabin at the same time and paddled at an average of 2.4 kilometers per hour towards Jayden's cabin. Cabins are 6 kilometers apart, and the linear system that models this situation is d equals 6 minus 4t, which if we write using y and x, would be y is equal to 6 minus 4x, and d equals 2.4 times t, which would be y is equal to 2.4x. Now, d is the distance in kilometers from Tyrell's cabin, and t is the time in hours since both people began the journey. We want to graph this system, and if we did, we'll find x and y intercepts. When x is 0, you're going to find that y is equal to 6, and if y is 0, x will be 1.5. Now for our second equation, if x was 0, you're going to find that y is equal to 0, and if y is equal to 0, you're going to find that x equals 0. Well, we need another point, so let's find something else on here. Well, if x was, say, 2, now we'll figure out 2.4 times 2, so y would equal 4.8. Now the other thing about this graph is there's no need to plot negative values because distance and time both start at 0. So we're going to plot our points and putting time along the x-axis, distance along the y. We're going to plot our points, and in the first case we've got when x is 0, y is 6, and when x is 1.5, y is 0. There's that one. In the second one, we have x is 0, y is 0, and when x is 2, y is 4.8. It's going to intersect at 0.9375 and 2.25. That's our intersection point. So what does that mean? Well, since the x value is time will be 0.9375 hours. And 0.9375 hours times 60 minutes in an hour will give me 52 minutes. And after 52 minutes, you can tell that we're 2.25 kilometers away from the cabin. That's our solution. Last question. I have a linear system for this. Wayne received and sent 60 text messages on his cell phone in 1 weekend. That would be R plus S equals 60. He sent 10 more messages than he received. So sent minus received equals 10. So if we let R to be X and then S would be Y, we could say X plus Y equals 60 and Y minus X equals 10. There's our two equations. If we subtracted X from both sides, you get Y is negative X plus 60. And if I subtracted Y or added X to both sides, I get Y is equal to X plus 10. Now I've got both of these equations written in terms of X and Y and in the form of Y equals. Now I can enter them into my graphing calculator and find the intersection point. So if we did this, I'm going to receive. And again, I'm going to start at 0. But this time I'm going to change my windows because I can send and receive up to 60 text messages. So I'm going to make both my axes go to 60. Notice now, I've plot my points for my x and y intercepts. When x is 0, y is 60, and when y is 0, x is 60. The second equation, unavailable curves, will be when x is 0, y is 10. And I need another point now, and 0, 0 is not going to pin on it, so I'm going to pick when x is 50, y is 60. That's that point there. Now I can draw my line through, and my point of intersection is going to be when x is 25, y is 35. Part B asks, how many text messages did Wayne send and how many did he receive? Well, we can see that he sent 35 and he received 25. The assignment is to be finished. Therefore,